Good day, students. Welcome to our lesson this week in elementary logic. In this case, we're going to discuss constructing a truth table. Before we proceed to constructing a truth table, so let us have a review first about logical connectors or operators. So this is a symbol for not or negation, and or conjunction, or disjunction, if then or conditional, if and only if, bi-conditional. The logical connectors link a compound proposition that consists of two or more simple propositions. So here are the type of compound propositions. Let us express it in symbolic form and determine how it's being read. So for this is read as not P, then this is read as not Q. So this can be read, for conjunction, this can be read as P and Q. For disjunction, this can be read as P or Q. For conditional, P implies Q, that can be also read as if P then Q. For biconditional, this can be read as P if and only if Q. Now let's proceed to constructing a truth table. A truth table displays the relationship between all possible truth values of the component propositions and the compound propositions of the former. Now let's have a truth table for a negation. Let P be a proposition. So P is either true or false. So not P, not true is false, and not false is true. So give the truth value of each statement. Number 1, 2 is not odd. So let us put the this is how it is written in negation form. So let us put the negation symbol outside. So not 2 is odd. So 2 is odd is false. Not false is true. Number 2, it is not the case that 49 is a perfect square. So put the negative or negation symbol outside. So not 49 is a perfect square. This statement is true. Not true is false. Now let's have a truth table for a conjunction. Let P and Q be propositions. So here we have P and Q. So since we have P and Q, we have two propositions. Now we're going to have 4 additional rows for T, T, and F, F. Then for the second column, Q, the rows are TF, TF. So P and Q. If both P and Q are true, then the compound proposition is true. False if otherwise. So meaning to say, if both are true, then the compound proposition is true. P and Q is true. Then it will be false for the rest because TF, FT, and FF are not both true. Okay? So for conjunction, only T and T will result to T or true. For example, give the truth value of each statement. Number 1, 2 is prime and 2 is even. 2 is prime is true. 2 is even is true. Then they are true. The compound proposition is true. 3 is odd and 5 is even. So 3 is odd, true. 5 is even, false. The answer is false. 7 is even and I am handsome. 7 and even is false. I am handsome, so it can be true or it can be false, right? So hopefully in your belief it's true. So, but whatever it is, since the first statement is false, so regardless of the second statement, whether it's true or false, so the answer is false. So if both are true, then it is true for and or conjunction. Now let's have a truth table for a disjunction. Let P and Q be propositions. So we have P and Q here. So P, T, T, F, F, for Q, T, F, T, F. Then P or Q. So let's have a column for P or Q. If at least one of P or Q is true, then the compound proposition is true. False if otherwise. So meaning to say, if there is only one true, so then the compound proposition is true. Okay, so since for the first row both are true, then it is true. Then second column T F, one is true, so that's true. FT, one is also true, then that's true. For FF, it's false. Okay, so meaning to say for disjunction, in the only case that it will be false if both of the proposition is false. FF is only F here. Okay, but is uh, the rest are true because it has at least one true. For example, uh, remember class, or is inclusive when it means either or both, or is exclusive when it means either but not both. In logic, or is always inclusive. So for example, give the truth value for each statement. Number one, 3 is odd or 4 is even. So 3 is odd, that's true. 4 is even, that's true. So the answer is true. Number two, 4 is even or I am handsome. So 4 is even, that's true. I am handsome. So it could be true, it could be false, but I hope it's true. So the answer is true because at least one is true. Since the first statement is true already, so regardless of the second statement, whether it's true or false, then the compound proposition will be true. Number three, 6 is odd or 5 is even. So 6 is odd, it's false. 5 is even, that's false. So the answer is false. Okay, because both of the statements are false. In disjunction, if it is both false, then the compound proposition is false. Truth table for conditional. The conditional proposition if P then Q, denoted by P implies Q, is true except when P is true and Q is false. Okay, so here again we have column for P and Q. So if P is true and Q is false, then it is false. TF is the only false here in conditional. The rest are true. T, T, FT, and FF are all true. So in conditional, TF is the only condition that is false. Okay? Now, for example, give the truth value for each statement. If 2 is odd, then 3 is odd. 2 is even. Again, if 2 is even, then 3 is odd. So 2 is even, that's true. 3 is odd, that's true. So the answer is true. If 4 is even, then 5 is even. 4 is even, that's true. 5 is even, that's false. So the answer is false. If 2 is odd, then 4 is even. So 2 is odd, that's false. 4 is even, that's true. So the answer is true. If 4 is odd, then 5 is even. So 4 is odd, false. 5 is even, false. So the statement is true. Okay? So TF is the only thing that is false for conditional. Remember, a conditional proposition is a proposition joined by the words if and then. So it is in the form of if P, then Q. P is called the antecedent while Q is called the consequent. A biconditional proposition has the form P if and only if Q. The proposition P if and only if Q, denoted by P if and only if Q, is true if P and Q have the same truth values. It is false otherwise. Now, let's have a truth table for the biconditional. So meaning to say, if they are the same, let's say same true or same false, T, T or FF, it's true. Okay, so both are true, then it's true. Both are false, then it's true. Then if it's different for biconditional, let's say TF or FT, then the compound proposition is false. Okay, so that's how you remember it. So, for example, give the truth value of each statement. Number 1, 4 is even if and only if 5 is odd. 4 is even, that's true. 5 is odd, that's true. So it's true. 2 is even if and only if 4 is odd. 2 is even, that's true. 4 is odd, that's false. So the answer is false. For number 3, 4 is odd if and only if 2 is even. 4 is odd, that's false. 2 is even, that's true. So the answer is false. 2 is odd if and only if 5 is even. 2 is odd, false. 5 is even, false. So the answer is true because they are both false, if and only if. Okay, so again, for biconditional, if they are the same, that's the compound proposition is true. Okay, so this will be your hint. Okay, so for not P and not Q, it's just the opposite. Okay, if it is T, then write F. If it's F, then write T. Right? Just write the opposite. For conjunction or and, only both true is true. Okay? For disjunction or at least one true to be true. If there's one T, then it's already true for disjunction. For conditional, only TF is false. Okay? Then the rest is true. For biconditional, both true and both false are true. If they are the same, then it's true for biconditional. So this will be your hint to remember the result for the compound proposition in each of these logical connectors. So if two propositions are involved for P and Q, then 2 squared is equal to 4. There will be 4 rows for the truth values. If three propositions are involved, let's say P, Q, and R, so that's 2 cubed equals 8. So there will be 8 rows for the truth values. Now let's proceed to constructing a truth table. For example, construct the truth table for P or Q or not P or Q. So first, since it has only two propositions P and Q, so there will be 4 rows. As you can see, 1, 2, 3, 4. Okay? So the first two columns will be for P and Q. So T, T, F, F. Okay? For Q, T, F, T, F. Alternate. Okay? And then what's next? So you decide, no? So let's say for the third column will be P or Q. So or, remember, pag P or Q, at least one T to be true. So since both true, so this will be true, then TF true, FT true, FF so false. Okay. Then next, not P. So for not P, just write the opposite of P. So opposite of true is false, opposite of false is true. So this will be F, F, and then true, true. For the pip column, so let's have not P or Q. So look at the columns for not P and Q. Okay, so at least one true to be true. So here we have FT, so that's true. FF, so okay, 2, 3, and T, so true. T and F, true. So since here F and F, so false. Then now for the entire, for the compound proposition for the given, so look at the third and fifth column. So or, so both true, so that's true. The F at least one is true, so that's true since conjunction or both true. So this true for the last F and T. So at least one is true, so true. Okay, that's how you construct a truth table. Now, this is called a tautology. A tautology is a compound proposition that is true for all possible truth values of its component propositions. Another example, P and not Q and P and Q. Okay, so in this case class, consider the grouping symbols. So here, since we only have two propositions here, P and Q, so for rows, T and D, and then FF. Then TF, TF. For the third, so let's have not Q. So opposite of true is false. Opposite of false is true. Opposite of yan. True is false. Okay, opposite of false is true. And then P and not Q. So look at the first and the third column. So and. So remember if and both true must be true. Okay, and then the rest will be false if they are different. Then for the fifth column, let's have P and Q. So look at the first and second columns. So again, and so both true is true, and then here TF it's false, FT it's false, FF is false also. Okay, and then lastly, here you're going to look at the third and fifth columns. So here and, okay, P and not Q and P and Q. Okay, so look at the main. So here look at the third, the fourth and fifth. So FT, so one is, so they are not the same. So since this is conjunction and so this is false, TF is false again, FF false again, FF is also false. Okay, so as you can see, all the results are F. So this is how you construct a truth table. So if this is the case, this is called a contradiction. A contradiction is a compound proposition that is false for all possible truth values of its component propositions. Again, for example, number 3, construct the truth table of P if P then Q, or P implies Q, if and only if not P, and P or Q. So again, P and Q, we only have two propositions. So T and T, F, F. And then Q, T, F, T, F. So here, let us uh, write the additional columns. So you can also have this way, no? Write the next columns before you answer it all. So now let us first have P and Q. Now, if you're going to ask, sir, what is the technique to determine what will be the next column to add? So the technique is that you look at the entire given. So of course, the last column will be the given, and then look at the grouping symbols and also the operation. So here, it's easy to get P if P then Q. So okay, implies. So in here, TF is false, and then the rest is true for conditional. And then not P, so that's the opposite. So F, F, T, and T. So P or Q, so P or Q, it's remember, or at least one T for to be true. So look at P and Q. So 3, 2 true, true. Then F T is also true, F F is false. Okay, and then not P. Look at not P. So look at the third, the port and the pip column. Again, look at the port and the pip columns. So here, and. Okay, so since and, it must be both true to be true. So, okay, so F T is yon for the third row. So both true is true, and then the rest will be false because ft is false, ft is also false, the f is also false. Okay, and then for the entire, so look, you're going to look at the second, oh, I'm sorry, you're going to look at the third and fifth columns. Okay, so if and only if, so bi-conditional, so it must be true to be true. Okay, so T, F, that's okay. For the third, both true, it's true. And then for the here, F, F, that's true. Okay, for the second one. Then the rest, for the first, TF, so that's false. For the fourth, TF, that's false. Okay, so as you can see, the results in the compound proposition are different. F, T, T, and F. Example 4, P and Q, P and not Q implies R, okay? So, or if P and not Q, then R. So, since we have three propositions here, P, Q, and R, we can, so 3 to cube equals 8, so we can determine the number of additional rows. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. So for P, for the first column, 4 T's and then 4 F's. Then for the second column, by 2's, 2 T and then 2 F's. Then for the R alternate of the F. Okay, then what will be the fourth column? So let's say not Q, because we need not Q. So opposite of Q. So alternate by 2's, F, F, T, T, F, F, then 2 T's. Okay. Next, we can determine the P and not Q. So P and not Q, look at the first and the fourth column. So and, so if it's and, it must be true to be true. Okay, look at the same. So this is true. The third one, the fourth one, that's both true. That's also true. Okay, then the rest will be false because they are different. And then for the last, we can add the entire given. So implication. Okay, so look at the fifth and third columns. Okay, so in here, TF is false. Okay, but you're going to look at the fifth column first before the third. Okay, based on our given. So here, TF, so that's false, and then the rest is true. Okay, so in this case, class TF is the only thing that's false. So if the truth table looks like this, I mean the last are not all true or not all false, then it is called contingency. A contingency is a compound proposition that is neither a tautology nor a contradiction. Okay? It is a contingency if the compound proposition in the last column are not true or not false. Remember, if all true, that's tautology. If all false, that's contradiction. If it is neither a tautology or nor a contradiction, then it is called a contingency. Okay, for practice exercises, construct a truth table for the following compound propositions and indicate if it is a tautology, a contradiction, or a contingency. So I'll be sending you a worksheet to answer with the same given for numbers 1, 2, 3, and 4. We're going to do the same for items number 5, 6, and 7. So construct a truth table, then indicate if it is a tautology, a contradiction, or a contingency. So class, let me share you this. Logic is the beginning of wisdom, not the end. This is according to Leonard Nimoy, an American actor. Always remember class, do mathematics to learn mathematics. Practice, improve, and stay curious. I hope you learned something in this lesson. Keep safe, stay healthy. God bless everyone. See you next time.